So perfect squares could be identified by noticing, hey, if I make a equal to 1, and if I make it so that half of b squared gives me c, then that is in fact a perfect square. So let's apply this to solving some problems. It all sounds very abstract right now, but as we do examples, this will become really clear and straightforward. And you'll see it's really not as scary as it seemed when we first learned it. Okay, so let's consider the following example. X squared plus 6x plus 8 equals 0. We would like to solve this by the method of completing the square. But before we do, we're very fortunate. This is an example that we can actually solve without the method of completing the squares. We could solve it by factoring. So we ask ourselves how to factor x squared plus 6x plus 8. Well, what are some ways we could break down 8? 8 is equal to 1 times 8. It's equal to 4 times 2. Those are the only possibilities. Well, we notice 4 and 2 add up to 6. So our factorization should be x plus 2 times x plus 4. If you don't believe it, check it. First is x squared. Outer is 4x. Inner is 2x. When added together gives us 6x. And last is 2 times 4 is 8. So this is the correct factorization of the quadratic. X squared plus 6x plus 8. And now we know how to solve this. The product of two numbers is 0. Either x plus 2 is 0, or x plus 4 equals 0. If x plus 2 is 0, we get x is negative 2. If x plus 4 is 0, we get x is negative 4. So x is negative 2 and x is negative 4 are the two solutions to the quadratic equation x squared plus 6x plus 8 equals 0. Why do we expect two solutions? Because the degree, which is the highest power of x appearing in the expression, the degree is 2. And whatever the degree is, we expect that many solutions. Whether they're distinct or real or not, we expect two solutions, and here they are. So we would like to solve this another way, with the method of completing the squares. So here is the method. We first would like to make the constant term disappear. So we subtract it from both sides, and we get x squared plus 6x equals negative 8. Now we ask ourselves, what is it that the c value should be to ensure that the left-hand side of this equation is in fact a perfect square? Well, we know, hey, a quadratic is a perfect square if we have a is 1, the coefficient x squared is 1, which it is here, 1 times x squared, and we need to know b over 2 squared is c. Well, let's find b over 2 and square it. b over 2, do some scratch work on the side, b over 2 squared is equal to 6 over 2 squared, which is 3 squared, or 9. Our c value should be 9. Why? Because half of b squared should be c for it to be a perfect square. So c should be 9. In other words, we want to see a 9 here on the left-hand side, but we don't see it. So how about we add 9 to both sides now? And what we get is negative 8 plus 9, or I could write 9 minus 8. We have just successfully completed the square. Completed the square means we have added whatever is necessary to both sides of the equation to ensure that the left-hand side is in fact a perfect square. And the left-hand side is equal to what squared exactly? Well, we saw before, in fact, x squared plus 6x plus 9 was the perfect square of x plus 3. If you do x plus 3 squared, if you FOIL that out, you'll get x squared plus 6x plus 9. We have completed the square by adding 9 to both sides. And what do we have on the right side? 9 minus 8 is 1. So the goal all along is to solve for x. So we take the square root of both sides, we get x plus 3 equals, I have a number squared gives me 1. I could think of only two such numbers, 1 and negative 1. So x plus 3 could either be 1 or negative 1. So we write it as a single statement plus or minus 1. So then we solve for x by subtracting 3 from both sides, and we get negative 3 plus or minus 1. Okay? And what's that? Well, two solutions. If we take the positive solution, we get negative 3 plus 1 is negative 2. If we take the negative solution, we get negative 3 minus 1 is negative 4. And there are the two solutions that we found by factoring. So, we have just successfully solved our first quadratic equation by the method of completing the squares. Not too tricky. All we need to remember is the c value should be half the b value squared.